Okay, so as usual, we are here to just continue with the first unit. Today we are going to finish the unit number one, that is the introduction to power semiconductor devices. So the last one point that is highlighted, so that is remained, so that we are going to cover today. Before that, just quick review of the last session we supposed to take. So that's why this quiz has been constructed. So definitely you can give the answer for this. So immediately, just in 1 minute, try to give the answer in the chat box. Okay, very good. It is started. So only three questions just I have written over here. That is triac is a unidirectional device. Triac has a dash dash layer analogy. When MT2 is positive with respect to M1 and MT1 and gate is positive, so that time what is the direction of current flow via which layers it flows. So yesterday that we have explained that which junction get reverse bias, forward bias, and with this configuration which layer comes into the picture. So in that way the current flow will be there. So definitely a review, it is expected after the this particular sessions that you supposed to go through the video, through the PPT and the other material also from the internet. So in 1 2 days definitely we will send that class notes, that is the additional PDFs related to that respective point, and the ebook also I will share with you so that you can take as a reference for this one. Actually the syllabus whatever it is there for this ESD, so that is a combination of multiple subjects. So not a single one textbook is sufficient for as a textbook or the reference book. So multiple books we supposed to just check out for the different this topics or the units, so that I will tell to you. Okay, so I hope who has how many, it's given the answer. So first question, that is the track is a unidirectional. No, it is a bidirectional definitely, because it is a combination of two SCRs connected back to back. Either one will be in a working state, so that's why it is in a bidirectional device. So it is a false. Next one, that is the track has dash dash layer. So only one student has given the answer, and that is the correct answer given. That is, it is the 6 layer analogy or the topology is there. That is how many layers are been used there in that the respective this what we can say the structure of a triac. So that was the question. And the third one, that is given by the many students, so I am also not remembering, but I supposed to just check out for the answer. So this is what the P1 N1 P2 N2, so that is the correct answer. And through which, and what is this P1 N1, that yesterday we have just seen in the PPT. So very good for this sharing your answers. Now today we will focus on a diac. पहिल्यांदा आपण SCR बघितला, नंतर आपण ट्रायक बघितला, आणि आता आपण डायक पाहणार आहोत. सो ऑल दीज डिव्हाइसेस आर फ्रॉम द थायरिस्टर फॅमिली. थायरिस्टर फॅमिली मीन्स व्हॉट? द कंट्रोलिंग फॅमिली. काय कंट्रोल करायचंय? तर पॉवर कंट्रोल करायची. कुठली पॉवर? इट मे बी AC पॉवर, इट मे बी DC पॉवर. सो इन दॅट वन इम्पॉर्टंट डिव्हाइस इज हिअर, दॅट इज द डायक. ओके, सो SCR मध्ये आपण बघितलं की इट इज जस्ट अ युनिडायरेक्शनल वन, की एकाच दिशेनं ते करंट फ्लो होत होता इन फॉरवर्ड कंडक्शन मोड. ट्रॅक मध्ये बघितले की आपण दोन SCR उलट्या दिशेनं लावलेत, त्यामुळं वन ॲट ए टाइम इट इज गोइंग टू बी वर्क फाईन, अँड विच इज हॅव्हिंग द कंट्रोल्ड बाय द गेट करंट. This is very important because there is no much difference between the diac and triac. What was the triac stands for? Triode alternating current. And here if you are looking the first sentence, so that is the diac, it stands for the diode for alternating current. So diode, our normal diode. So how it comes in this particular diagram? Because the two diodes are connected back to back, which forms a construction of a diac. And where the main application of this one, so it is useful for the AC, that is alternating current power control, as well as in triggering the triac and other thyristor based circuit. So these are the general applications of the diac. It is also bidirectional semiconductor switch like triac. That is also bidirectional. This one is also bidirectional, but only the difference is in next slide we will see that. The diac starts conduction electric current if the applied voltage goes beyond the breakover voltage. So what is the meaning of this sentence? So in just a second. So what is the meaning of this sentence? So in the next slide we will come to know. And the last sentence, that is the diac don't have the facility of controlling the controlling by gate terminal. गेट टर्मिनल ह्याच्यामध्ये नसते की जी आपण SCR किंवा ट्रॅक मध्ये पाहिली होती. So this is the symbol for diac, and if you can see, observe, diac is consist of two normal diodes which are connected back to back. So anode of one and cathode of one, they are interconnected, and that is the first terminal and second terminal. So diac has only two terminals, and the actually physically which is available the diac in the market, so that picture is also provided in this slide. And this is the symbol for this particular diac. Normally the terminals are being termed as a it is bidirectional, so we cannot bifurcate, that is one is anode and one is cathode. So normally it is been given the names as MT1, MT2, MT3, like that. So this MT, it stands for the normal the main terminal, that is what MT1 and MT2. So it may be positive, it may be negative at a time. So that is what the terminology of this particular diac is there. So this diac construction we supposed to remember. Here no gate terminal is there. Now little introduction about this diac. That is, the diac is made up of a 5-layered structure. So just we will go ahead and let us see this first. So this is what the first diagram, if you can observe. So how many layers are there, so that you can observe. So two terminals are there, and it is the combination of two diodes connected back to back, that is P and N layers will be there of both the diodes. But the MT1 and MT2, they are connected to both the layers. Both the layers means here you can see the positive of one diode and negative of one diode. So that is interconnected, and that is the name is given one terminal. That is MT1 here it is given. So here also the negative and positive. So both are connected to the MT1. Positive and negative both are connected to MT2. Got it? So this is the what concept of this actually construction during the manufacturing of this diac. So N1, P1, N2, P2, and N3. So like this, the 5-layer analogy is there for the this diac, and the MT1 and MT2 are the terminals. So it is written over here. The layers closer to the terminal are the combination of both positive and negative layer. That is what it is there. So for MT1, N1 P1, for MT2 P2 N3. When the voltage is passed to the terminals, the layers with respective polarity to the voltage gets activated. What is the meaning of this sentence? Means जर MT1 पॉझिटिव्हला कनेक्ट केलेली असेल तर P1 layer comes in the picture. If MT1 is connected to negative, then N1 layer will come in the picture. Like that the triac yesterday we have seen in the same manner. तसंच MT2 च्या बाबतीत सुद्धा if MT2 is positive, then P2 layer comes in the picture. If MT2 is negative, N3 layer comes in the picture. Like that, this is the meaning of this particular introduction. Now, next is that uh, as we have said that it is a bidirectional, and normally it is been used with the AC source. AC source म्हणजे काय तर positive half cycle, negative half cycle. So during that the positive half cycle and during the negative half cycle, what is happening? So that is nothing but the working principle of diac. So during the positive half cycle, if you are looking, the MT1 becomes positive with respect to MT2. And during the negative half cycle, the opposite case is going to be happen. That is, MT2 becomes positive with respect to MT1. And as MT1 becomes the positive, MT1 becomes the positive. See the cursor. Positive means which layer comes in the picture? P1. So that's why it becomes P1 over here. MT2 is negative. That means which layer it comes in the picture? N3. So this is what the combination it becomes. The layer becomes P1, N2, P2 and N3. In this way, it is going to be present for this particular positive half cycle. That is, MT1 is positive with respect to MT2. And the current is going to flow via these layers only. P1, N2, P2 and N3. How? Because if you are looking here, whatever it is written at the junctions, so here MT1 positive आहे म्हणजे the current will flow from upper side to downwards, and due to that P1 N2 junction हे forward bias आहे. At the same time P2 N3 junction हे सुद्धा forward bias आहे, परंतु at the same time N2 P2 हे जे जंक्शन आहे that is in reverse bias. मग करंट कसा काय फ्लो होईल? The answer is that so when this particular the voltage between this MT1 and MT2, when it crosses after the threshold value that is known as the VBO, that is breakover voltage. When it crosses the breakover voltage as that of the same SCR or track, when it crosses this VBO, it will just flows the current which goes beyond the holding current, and this will goes in a on condition, or it will become on. It is the working of this diac. And when it crosses this breakover voltage, this reverse bias, whatever the junction is there, whatever the depletion layer it is been formed, so it will get vanish or it will get destroy. So how it is going to be work? In the same manner in the next case, that is if you are making MT2 positive with respect to MT1, that is negative half cycle if we are considering here. So MT2 positive म्हणजे P2 layer comes in the picture, then N2 as it is, and MT1 हे negative आहे, so N1 will come in a picture. So that is whatever the electrons will come from this MT1 terminal, so they comes in a N1 layer and they are going to be trying to flow in this direction, electrons, and the direction of current will be in opposite, that is from positive to negative, that is as the arrow is shown in this diagram. So the current flows through P2, N2, P1 and N1. So these are the layers being used for getting the flow of current. The same case is happening here also. That is P2 N2 junction become forward bias, P1 N1 junction also forward bias, but at the same time N2 P1 is a reverse bias. So when this voltage between the MT1 with respect to MT2, but in this case, if we are looking for the voltage between MT1 with respect to MT2, so in this case it is positive, but in this case it is negative. Voltage between MT1 to MT2. Even though it is positive, it is negative. But if you are taking the term as V MT1 with respect to MT2 for both the diagram, so it is the positive voltage and it will be the negative voltage. So when it will just crosses again the reverse breakdown voltage, so the current flow will be more, or the sudden current is going to be flow. And this is how the current is also going to flow via this P2 N2 P1 N1, and the diac will be on in either direction. So this is what the bidirectional working principle of the diac. So with the help of the characteristic, that is VI characteristic, also we supposed to just show it. And this is what the same explanation whatever we have done, so that is written here. That is when the MT1 is positive and MT2 is negative, current flow through this layer, and when MT1 is negative and MT2 is positive, current flow through these layers. So that is explained. So this is what we are talking about the VI characteristic of diac. So VI characteristic, that is one, it is in a when it is in a forward bias and when it is in a reverse bias. Means what? दोन कंडिशन आपण बघितल्या, एक करंट MT1 कडून MT2 कडे फ्लो होतोय आणि दुसरीकडे MT2 कडून MT1 कडे फ्लो होतोय. So this is how the current definitely the x-axis contains the V, not only the V. If you are writing in detail, so it is V, what was that, MT1 with respect to MT2, MT1 with respect to MT2 इकडे पॉझिटिव्ह आणि अपोजिट साइडला V MT1 with respect to MT2 इट इज निगेटिव्ह. तर ज्यावेळेस पॉझिटिव्ह व्होल्टेज तुम्ही वाढवत 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 जाता, तर एक असं लिमिट येतं की VBO1, दॅट इज ब्रेक ओव्हर व्होल्टेज. ते जर व्होल्टेज क्रॉस झालं की त्यावेळेस सडन करंट राईज होतो, विच क्रॉसेस दिस पर्टिक्युलर IBO, or it is a holding current, actually IH. If it will be asked to me, I will write that. So they have given the blocking current, म्हणून त्यांनी IB दिलेलं आहे. But the whatever the terminology we have studied, so that is holding current. Blocking current, holding current, the meaning is same, but only the names it is noted is different. So you can choose any one. तर ब्रेक ओव्हर व्होल्टेजच्या वर ज्यावेळेस व्होल्टेज जातं त्यावेळेस हा करंट सडनली हायर होतो आणि डायॅक विल गोज इन अ ऑन कंडिशन. So this is what it is written, that is the conduction state for positive half cycle. तेच नेगेटिव्ह हाफ सायकल मध्ये निगेटिव्ह व्होल्टेज वाढत जाणार आहे, दॅट इज व्होल्टेज ऑफ MT1 विथ रिस्पेक्ट टू MT2 ते निगेटिव्ह होणार आहे. ते सुद्धा असंच ज्यावेळेस वाढत वाढत जाईल, परंतु जोपर्यंत होल्डिंग करंट पेक्षा जास्त करंट होत नाही किंवा व्होल्टेज ते ब्रेक ओव्हर रिव्हर्स ब्रेक ओव्हर व्होल्टेज पेक्षा जास्त होत नाही, तोपर्यंत इट विल बी इन ऑफ कंडिशन. अँड वन्स इट क्रॉसेस दॅट पर्टिक्युलर, सो अगेन द सडन चेंज or the sudden flow of current will takes place and this particular VI characteristic will be formed for the diac, and that is what the first quadrant and third quadrant, they are mainly used in SCR or the TRAC or the diac. First quadrant and third quadrant. So first is for positive half cycle and the third is for the negative half cycle. So in both the cycles, that is positive and negative, this diac is going to work in a two direction, that is, so that's why the name it has been provided, that is bi-directional. So this is what how it is going to be work, and the current, so it is nothing but the this what the flows through that the current of mt1 with respect to mt2. So that is also here in first quadrant it is positive and it is a negative in the third quadrant. So this is how it is going to be. It shows the direction actually, okay, from where to where this particular current is going to be flow. So this is what the there. Now, the actually, if you are going for practical application or the this uses of the diac, so how it is being used. So that is one of the this simulation. I have just taken the diagram for LED blinking. As I told की पॉझिटिव्ह मध्ये पण वर्क करतो आणि निगेटिव्ह मध्ये पण वर्क करतो हा. मग त्याच्यासाठी एक कसं आपण ऍप्लिकेशन दाखवू शकतो, तर एक एलईडी इथं D3 हा कनेक्ट केलेला आहे. एक डायॅक इज बीन कनेक्टेड ओव्हर हिअर. सो इन द प्रोट्यूस ओनली वी कॅन डू इट, and the input is the AC source, and for that these two diodes are been additionally been used, one capacitor for as a what we can say current limiting, the R1 R2 resistors are there, and this is the current holding circuit capacitor is been used over here. So by making such arrangement we can see that how the this particular diac will work and what is the effect on this particular LED. At the same time the waveform, that is CRO, is also been connected over here. So you can connect that CRO also to monitor that, okay, how or what is happening in the case of diac. That is the multiple waveforms are there. So one waveform you can just connect to the AC source and another one is connect across the diac, so that you can check the difference or the effect on the working of this particular diac. At the same time the voltmeter is also been connected over here, that is it gives that the respective voltage, and it gives that whatever the input supply it is been provided, so from that how much it comes across this particular the load. So as a load here the LED is been used. So this is the practical approach it is been shown here, that is by using the diac. The another application in the first slides we have read that it is used for firing the triac or the other thyristors. So that is also one of the applications are there. So what are the other applications of this diac? So that we will see in a short one. That is in next unit we supposed to just see the few of the applications also. So but here as an introduction part only we will go for the applications of diac. So heat control, that is a room temperature control. Then light dimmer. So with that the you can increase decrease automatically the light. So for that also this diac can be used. Then the flasher, LED flashers, that is the dancing light like that, the there also the diac can be used. So why we are I'm just telling this intentionally the applications, because now in this semester you are going to face the HMP, that is a hardware mini project or mini hardware project. So that time you have to prepare any one hardware circuitry depending on the your syllabus or the related to your field. Got it. So instead of just going big projects which you are going to prefer for the your final year, so here the small units you can just prepare, or small ideas you can take from this particular topics, and you can prepare the hardly it will take 50 to 60 or up to max 100 rupees with the battery and all that. So this project you can prepare for in the HMP. So definitely from the next week that HMP teacher will be allotted to you, and uh, he will guide you. But by that time you supposed to just bring your ideas and discuss with that HMP teacher, so that he will also help you in that regard. So that is what the by through this subject also you can just take few of the circuits, and you can mount, you can build, you can manufacture, you can produce, and let us say that how much easily and sincerely and very accurately you can go for this particular HMP, because the marks are also there in the university curriculum. So these are the few applications of this diodes, the diox, that is the diode for AC, respectively. Where the AC applications are there, so these diac tracks are mostly been used in our fan speedometer and all that. There also it has been mostly been used nowadays in a IoT also, the automatic that light dimmer and all that. So there also this type of the diox and the triacs are been used. So how it is been used, so that you can search on the Google and you can take an interest in that and try to build the project, small projects under your HMP. uh, so this is what the about this first unit. I hope all the points we have covered here, so you just check out or you go through the content. So tomorrow we have a lecture, so that time we will conduct the test. So I will send the link on a email. So just check at the respective time, the check the email, get the link, open it, and write the answer. So I hope instead of going for the next unit, we will stop over here. So if any query or the suggestions or the anything else regarding to this first, you can just tell me or you can discuss here. Still we have the 10 minutes. So all are there, or just I will check out that. Okay, 61. Yesterday also 61 were there. So what about the other 10? I didn't get. And those who are here, 61. Out of them, how many are physically present? Can I check? Dhanraj Bosle, have you joined?
Yes, sir.
Okay, okay, okay. Then Vijay Salunke.
Yes, sir.
Okay, okay. So first unit we have completed. So tomorrow just be appear for the test, and on a priority just fill the scholarship forms. And if you have filled the scholarship form, so the link it is been provided to you. So please fill that link also. It was provided on our group long back. So please fill that. Okay, so no query. CR madam, have you discussed about that what we vocational training with the HOD?
No, sir.
So if the session is there, so please put that point there and just inform to other students also, those who are not in the that respective elective. Hmm? That is also because that is must, because I think after this semester you supposed to go for that gate training and all that, so that time you may not get the time for the this 15 days vocational training, because this vocational training is a must. 15 days and certificate plus report, all you supposed to submit. So accordingly the instructions will come, but that time it will not be the late one. So right now only you can just have a discussion and let us see what happens. Okay, so we will stop here, so please put your attendance and you can go for the next session. Thank you.
हेलो सर.
Who is there? कौन है? Hello.